Okay, this is the orientation system test. We need to show that it can detect position XYZ planes. We have the orientation breakout board hooked up to the Raspberry Pi. We also have the ADC hooked up to the Raspberry Pi with the sensor module hooked up to that. And the Raspberry Pi is being powered by our power board along with everything else. Okay, this is just the bottom of the code. I'm showing here that I'm keeping in a sleep break here at the end of the code for about 1/3 of a second, just because it can be a lot of data to try to capture at once, and it's hard to open the file on the Pi itself afterwards if we don't have some kind of buffer. Okay, so now I'm going to run the code, and I'm going to have it in this initial position, and then after about 5 seconds, I'm going to move it to another position and hold it there for 5 seconds so we can see that it recorded 2 separate positions. Okay, and the code begins. Now I'll move it. Okay. Exit out of the code, and I'll open up the log file now. Okay, so we got this open. All right. What is going on? Okay, sorry about that. I scrolled too far. All right, so here we have heading, roll, pitch, accelerometer readings, magnetometer readings, and gyroscope readings, all in XYZ, and system time over here on the right. As you can see, with this timing and with the 3.3 second sleep, that was basically the only delay outside of a small microsecond delay between readings. So we were well below the 500 millisecond requirement. This is position 1. As you can see, it starts at 25 seconds and ends, I start moving it around 35 seconds. So I held it there a little long when I was talking earlier. As you can see, we get pretty consistent readings here. Then this is when I'm turning it. And now for the next 5 seconds, there we go again, scrolling too far. The next 5 seconds, we hold about pretty consistent readings here, starting at about 33 seconds and running to about 39 seconds when I let it go and it started flopping back to its original position, and I cut the code. So as you can see, once I held in a new position, pretty consistent numbers. It was lying down like this originally, which is why we got more consistent numbers before. In this case, I was holding it in my hand in the second position, which is why you get these small variations. Hand obviously isn't completely steady. But as you can see, it records in the XYZ planes for many different readings, and it does it consistently, and it does it within our 500 millisecond requirement.